The problem with installing solar is once you start, you just can't stop. I installed this 9 kilowatt array about 2.5 years ago, and after the first year's analysis, I knew it was going to pay off. And I really liked having those months when my utility bill was zero. Let's face it, I want every month to be zero. So I've been looking for ways to efficiently expand, like adding panels facing west and southwest. Then it occurred to me, I have a shed with some available real estate. It's not ideal since it faces west and it has some trees surrounding it. There'll be a little bit of shade, but it already has AC power run to it. So if I use AC microinverters, I can get a super cheap install and boost my power. Plus, it has a white roof, so I can check and see if the bifacial solar panels will get a little bit of reflection off that and boost the power output. Welcome back to Projects with Everyday Dave. Let's get started installing solar on my shed. Now the shed is a pretty small build, so almost everything we need to install our panels is right here on this table. I'm going to use these aluminum extruded rails from K2 Systems in order to mount all of my panels. And one rail will reach all the way across my shed, but if you have a longer install, they have a connector bracket that will easily connect multiple rails and make it longer. To hold these rails to the roof, I'm going to use these L brackets from K2 Systems, and they will mount right to the side of the bracket, and I will connect them to the roof with these E-Jot fasteners. I used this particular one on a previous build, and it has a really nice cupped washer that seals to the top of a corrugation. However, my corrugations have a bump on the top, so this doesn't seal very well to that. So I'm going to use the flat washer for sealing in the valley. It's not ideal to put fasteners through the valley, however, it's a shed, and I know these seal well, so we're gonna go with that. For connecting the panels to the system, the one that goes on the end, I'll be using this Yeti clamp, which slides in the end of the rail and attaches the underside of the solar panel, so there's no exposed fastener on the end, and then I can put a cap on the end of that, and it will completely clean up the end of the rail system. The other reason I'm using this Yeti clamp is the rail isn't long enough to cover all of my panels, and this allows me to run the panels right to the very edge of the rail. For the mid clamp, I'll use K2 Systems self-grounding clamp, which is really nice. I don't have to run separate ground to every panel. This bites in and cuts through the anodized coating on the panel and grounds it to the rails. These are very easy to install. I just put it in and turn it, and now it's ready to receive panels. I'll be using only 4 microinverters for the 8 panels on this shed because each one of these microinverters can handle 2 inputs. I've been testing these Northern Electric Power BDM600 microinverters using my test rig for several months now. They've performed really well, so I want to use them on my shed and get some larger scale application data from them. These are the easiest inverter system to install I have ever tried. Simply plug in your panels to the MC4 connectors, and then the microinverters connect one to another in a daisy chain. And then I'll be able to use this extension cable to run directly from the plug on the microinverter into my combiner box. So there's no box on the roof that's required, no extra wiring, it's super simple. To connect the microinverters to our rail system, I will be using these grounding clamps, and they work the same way, just a quarter twist. You can slide it up, slide your inverter in there, and tighten it back down. To manage the wiring, I have a couple different styles of clips. This particular clip will slide on the edge of the solar panel to manage the wires on the panel itself. This clip slides on the rail system and allows management of wire directly to the rail. This clip will hold wires in the rail, so I can run wires down the rail and manage them into the rail with this simple snap-on clip right on the top. If I need to attach something in any other way, I have some zip ties for that, and you want to be sure and use UV stable zip ties so they don't break down over time and release your wires. Managing the wires up under the panels on the roof is very important so that you don't have snow or other things catching them and causing problems later on down the line. In order to ground our system, I need some number 6 grounding wire, either solid or braided like this. 2 grounding clamps to attach them to the grounding rod. Because it's out at the shed, I'll be installing 2 of these 8-foot grounding rods. At least here in the US, code requires 2 grounding rods unless you can prove the conductivity of the first one, so it's easier just to put 2 in. Then because each one of the panels is grounded with a mid clamp, I simply have to ground each row of panels with one of these grounding clamps which, you guessed it, slides into the rail, just like every other one of K2 Systems mounts. And then I can attach my grounding wire, and that grounds one entire row of panels. And I have 2 of them, 1 for each row. I'll have 2 rows of 4 panels. That will ground our system. Now, that is all I would need if I was doing standard solar panels with regular MC4 connection wires on them. However, half of the panels I'm putting in are going to be the bifacials, which have the very short extensions. And in order to extend those up to the microinverters, because I'm going to put them up under the first row to limit shading on the back side, I will need some PV wire. This is 10 gauge PV wire. It's important to use the right wire for this because it has to be UV stable as well. And then I will use some standard MC4 connectors and a crimping tool in order to make those extension cables just for that row of panels. Now that we have all the materials we need, let's get to work. All right, this is a fairly small install, and since the roof is pretty square, I can just use the edges to determine where to put the rails. I'm going to have 2 sets of rails about 44 inches apart. One for the lower string, one for the upper string, so I'm just going to measure from the edge of the roof and use a wax crayon to mark the roof where the bolts are going to go. I'll mark where each bolt goes so that I can be sure it'll hit a rafter because I want it to go into structure. The first one will be 11 inches up from the bottom, 2.5 inches in from the edge. So that's where the first bolt will go. There's a rafter right along this edge. Next one will be at 55 inches. This one was going to be 5 inches down, but I think I'm going to put it right in the top rim, 49 inches from the edge. Okay, I'll mark the other side. We'll put the 2 end bolts in, run a string, and then we can mark all the rest and get all the bolts installed. I'm going to use 2 different size drill bits, a larger one that matches the shaft of the bolt, and a little bit smaller one that'll just act as a pilot for the threads. There we go. Very secure bolt, ready to receive our L bracket. I'll put one on each end and we'll run a string to mark where all the middle ones go and shoot them all in. Okay, drill them and shoot them. I'm going to temp set the L brackets that hold in our rail, because if I tighten them down now, they'll twist and it'll be hard to get the rail attached. So I've already set these nuts towards the top of the bolt, about as high as I can put them, because I want to hold the panels as far up off the roof as possible and make sure we get enough light reflecting behind the bifacials. So just drop a washer on the nut, on the bracket, another washer. All right, let's go ahead and put the rest on. Now that all the L brackets are in, let's go ahead and attach the rails. K2 Systems 44X rails are very lightweight and easy to handle, and in my case, since I'm only putting up 4 panels, I don't have any joints. One rail will work for the whole thing. I'm just going to quickly stage them where they go, and then we'll attach them. These have a vertical slot, so the T-bolt can just slide right through the hole and then into the channel. Super quick, easy setup. How tight? Just finger tight. We're just getting them loosely set. Clockwise. Slide it in, put it in the slot, twist clockwise. Spin a nut on. Now we have all the rails temp set. I'll run a string line down the edge, get them all tightened up, both the bottom and the top, and then I can put in the microinverters. I'm trying to maximize the amount of space between the roof and the panel, so I'm going to set the rail at 5.5 inches off of the roof. I'll set the top and bottom rail with a tape measure, and then we'll use a string line to set the middle. Now that the top and bottom rails are set to the right height, I'll use a string line stretched across the top and bottom rail to set the middle two rails to match. That way we get a completely flat array. Stretching a string line from the top and bottom rail makes it super easy to get everything perfectly flat. I just lower the center rails below the string and then raise them up till they just touch and work my way across the roof. So I can put the wires where they will go and secure them as I put the panels down and make sure that there aren't any exposed wires. In order to do that, I've taken the dimensions of my bifacial panels and laid them out, and they will be exactly the length of the rails that I already have on the roof. In order to minimize shading on the back of the panels, I'm going to put all of the microinverters up under the monofacial panels. This system will be laid out a little bit different than a typical one because the last two panels I'm going to put one module per microinverter to make sure I don't have any clipping and I can take all the data I need to for the performance of the system. Typically, every two panels would be connected to a microinverter. So our first two bifacials will be connected to a microinverter up under the top one. The next two top panels will be connected to a microinverter under the second top panel. Then I'm going to connect one top panel and one bottom panel to this microinverter so that these last two panels can be independent on their own microinverters. In order to position these inverters, I took dimensions from the end of the rail to where I want to place them so that they will land to the left side of each module. I'm putting the microinverters to the left side of the panel because I'm going to be starting on the left side of the roof and working my way to the right. It makes it easy to plug in with the panel standing on its edge and then lay it down and secure it, and everything will already be in place. Each one of the microinverters has two barcodes that correspond to the two inputs. The first input is 0 and the second input is 1. For these last two inverters, where I'm only using one input, I've made a couple of blank plugs, and it looks like it has a wire in it, but actually, I'm just using it to seal the end. There's no plug, so they won't make an electrical connection. It's just to waterproof the last two connections, so there won't be any corrosion or point of water ingress. Each one of the microinverters comes with two barcodes. These barcodes are the barcode for input 0 and input 1. And when I get the microinverters placed on the roof, I'll come back to the sheet of paper and stick the barcodes on the paper. So when I load everything into the gateway and do all the tracking, I'll know exactly what each panel's performance is. So now that I know where to place each module, I can use a tape measure, mark the rail where each one of these goes, and get them secured to the rail. This is the very first microinverter in the string, so we need to close off the connecting cable with a plug. Now it's sealed, so no water can get in. I'll just coil it up and attach it securely underneath the panel. Installing the microinverters is pretty easy. Now the cables are a little bit longer than I need for my application, so I'll just take advantage of the extra depth in the rail and coil some of the wire up underneath the mount points. That way I don't need extra clips and it controls the wire for me. One of the things that makes these microinverters so easy to install is they simply daisy chain with one single plug that snaps together and is watertight. Now, in order to protect the cables, I put a little piece of plastic under the mount points for the inverter. That's probably not necessary since the bolts for the K2 mounts don't go past the nut, but I just want to make sure I don't have any issues. These are paint cutting nuts, which make sure there is an actual metal-to-metal contact in order to guarantee a grounded connection between the inverter and the rail. That's the grounding system for the microinverters. In order to secure the plug, I put two zip ties around the rail. I just want to make sure that it never comes loose. And I make sure to use UV stable zip ties, even though they're under the panels. If you don't, they will degrade over time. Then I use a few zip ties to just secure the wires to themselves and around the inverter. I don't want any of them sagging over time and catching on snow or something underneath the roof. I make the final connection to the microinverter up at the top rail. I wouldn't need to do that, except I'm using separate microinverters for the last panels. That will eliminate any clipping and allow me to get data for analysis I'll do in the future. A couple of final zip ties secure the cable in place. I want to make sure that there's a soft loop anywhere I make loops in the wire. We don't want it to be actually kinked. All right, now all the microinverters are installed. We can start putting the panels in. I'll secure that one sagging wire up underneath one of the solar panels when I install them. I left the plug for the final inverter coiled up right at the edge so I can reach it later. I can daisy chain 7 of these inverters in a row, and I only have 5 on the roof. So later, if I want to add a few more, I can just reach up, connect it to the end plug, and put several more panels in series with this array. Now I can grab the barcode stickers off of each one of these and apply them to my sheet of paper that has the layout for my panels. On this array, the bottom row of panels are going to be bifacials, and bifacials have very short leads for the MC4 connectors. So I made up a stack of red and black extension cables that will allow me to extend the length of the cable all the way up the panel and underneath the top row. That way I can make sure there's no wires or microinverters blocking the reflections off the roof. That way I can show the best case scenario for any kind of possible solar gain from reflection off the roof. Okay, all the extension cables are put together. Now we can secure them to the panels and start installing. I'm going to use these stainless steel clips that hook right on the edge of the aluminum channel of the solar panel and the extension cables to route our cables up off the end so they'll be out of the way when we set the panel. The stainless steel clips I'm using are pretty inexpensive and they work really well for attaching wires to the side of solar panels. Pretty much all solar panels have the same general flange thickness, so they work with pretty much any panel. The one drawback is they're very difficult to get off. If you have a slot screwdriver, you can slide under it, they come off pretty easily, or you can twist them off. Okay, I've routed everything along the edge as much as possible away from the cells since we're going to try and get reflection off the roof onto the back side. But I have to dip back to the inside here where the cross rail is coming across so that I don't pinch the wire. So there's a little bit of in-out going on there. And then we'll deal with the ends up on top of the roof. The bifacial panels are very heavy. Getting them up on the roof is a bit of a challenge. Time to get the whole family involved. I thought it would be pretty easy just to have my boys climb up both sides of a ladder and hand the panel up on the top of the roof, but in retrospect it turned out to be a little bit more challenging to do it that way than I thought. The rest of the panels we just fed up over the edge or up the end ladder, and I carried them to the final location.
Oh boy, that's heavy. Yeah. Got it?
No, I need you to help lift down from down there. Push it up over the rails. There you go, set it up there. Got it. All right, let me have it. It's critical to set the first panel in the right spot, and I aligned all of the rails so I know that they're straight and square. So I can set this one exactly on the edge of the rail. Since I'm using Yeti clamps, I don't need to have any of the rails sticking past. They can go right on the edge.
No.
Lift. Lift. Okay. Wait.
That rubbed on the roof all the way up.
Yeah. A little more. There you go. Once we had a process down for handing the panels up, it got a lot easier. Since the microinverters are all already put in place, I can manage the wires up top, just plug them into the microinverters, make sure that everything is securely attached up under the panels or to the rails, and move to the next panel. Each panel just clips right into the MC4 connectors on the microinverter. No special wiring required. You probably don't need 4 people to do it, but it's pretty convenient just to have 2 below to hand it up to 2 at the top. One of the nice things about putting these panels on my shed is the roof is close enough to the ground we can just hand the panels up and not have to carry them up a ladder, which is much harder to do. We put the bottom row in first, making sure everything is straight, and then it's very easy just to put a spacer in to hold the top panels up about 1/4 inch or so from the bottom panels. I left the last 2 panels off so I could run the ground wire and do all the final wire management, and then just place the last 2 panels in to finish it off. And we'll attach those from a ladder off the edge of the roof, and we're finished. I have 2 grounding clamps. We need to ground each string, so I'll put one on this rail and one on that rail, and we'll connect the ground wire between them. This system is super easy to wire. We have 2 wires to deal with at the end. Since all of these microinverters daisy chain together, there's just one pigtail that plugs in, and then I've put a gland on the end of a conduit. That conduit will carry our pigtail all the way down to the breaker panel. And then we have to have a number 6 ground wire connected to each row of panels. So one connection here on this rail, one connection on this rail, and then I will use a clip to hold them to the edge of the panel so everything stays up nice and neat, and that's all there is to it. We're ready for the last two panels.
Really, Dad?
Yeti clamps will be very convenient in this case. I just slide them on before we drop the panels down, and then I can pull them out and tighten them afterwards. You know you've chosen well in life when your wife is willing to help you put solar panels on your roof. It's good to be blessed with such a wonderful family. The last couple panels are a little bit tricky as I start to run out of space, but I shifted the whole array to the back of the shed so I'd have a little bit of walking room at the very edge. Last panel was the most challenging as I was trying not to knock my son off the roof, but I needed someone to hold the panel up while I reached underneath the other panel to make the final connections, since that optimizer is up underneath the monophase panel. Then from the ladder I could just tighten the last Yeti clamps and it's all finished. Yeah, you can see there are no wires hanging down. Lots of clearance underneath. Everything nice and tidy. All right, now that the hard part's finished, the array is all installed. All I have to do is connect it up to the grid. So let's get wiring. I have a very simple solution for bringing power in the shed. We'll use this 125 amp Siemens load center. It's very inexpensive, it's less than $30. It has 2 slots and 3 lugs, neutral, line 1 and line 2, and then in order to connect ground, we'll have to add a ground bar. We'll use a 20 amp double pole breaker for the power coming off the roof, and we'll bring that power in from the bottom. And then I have 2 15 amp breakers that we can use, one for lights and one for an outlet, and that's all we need. To bring the power in from the house, I'll just connect to my conduit with a simple connector, and then power off the roof from my flexible conduit. I have a connector for that, and then 2 clamps for the ground wire entrance and exit, which needs to go out to our grounding rod. Then I have a package of stickers that will help us identify the backfed breaker on the breaker itself and on the panel. It's very important in case someone is accessing it later and they disconnect a breaker. They would not necessarily expect the possibility of power to be fed through this. Now the reality is it's a grid tie system, so if the power goes out, this will turn off also, but it's required by code to make sure that the breaker is labeled as backfed. So let's mount it and get it wired up. Mounting this box is super easy. I have a conduit carrying the line from the house coming up from below, and I can just slide the wire through and set the box on that. Then the conduit for the microinverters is flexible, so I can just bend it out of the way, feed that cable through, and slide it in with no problem. Use a couple of clamps to get it secured to the board, and we're good to go. Strategically, I want to keep my number 6 ground wire continuous all the way through the breaker box and outside to the ground rods. To do that, I just feed the ground lug onto the wire before I screw it into the terminal. Then I don't have to break my cable anywhere. So all I have to do at that point is secure the ground lug in the box and feed the cable through the bottom of the box, and then zip tie it along the conduit and feed it out the bottom of the shed so I can connect it directly to the ground rod on the outside. No breaks. To ensure I have sufficient grounding, I'm installing 2 additional grounding rods at the shed. National Electric Code requires that they be 6 feet apart, and typically our ground's pretty soft and I can just push them into the ground with my tractor, and I thought I would be able to do that here, but it's been very dry summer, and so the tractor couldn't push them in without bending them over, and I had to pound them in. Each one I was able to get some distance in, but finally I had to switch over to the hammer and go back and forth between Jordan and I as we pounded and pounded and pounded until we finally got it into the ground. The easy part then was taking the 2 grounding lugs and securing the cable through them to the top of each grounding rod, and then running it just below the surface to make sure it doesn't get hit by any mowing equipment. Now we're ready to make the final connections inside. I like to bunch up a little bit of extra wire in my box. That's not recommended. It's just what I like to do in case I have to change my mind later. I have extra wire to do it. So the bottom bar will be the neutral. Then we'll have line 1 and line 2 coming in from the house. This is power to the box. And then we have the solar coming in from the top, and that'll feed the bottom breaker. I've used a lot of different wire strippers over the years, and this one I'm using now from Klein Tools is pretty handy. I really like the way it works. I secure the neutral to the neutral bus from the house, and then line 1 and line 2 to the line 1 and line 2 lugs in the panel, and then the ground to the ground bar. Now I'll make sure all my breakers are in the off position. And I have 3 wires coming from the solar array. We have a line 1, line 2, and a ground. So connect the ground first. Then the 20 amp 2-pole breaker will carry line 1 and line 2 from the solar array. A little bit messy, but should work. Then I want to make sure and add a label so everyone knows that this circuit breaker is back-fed and a photovoltaic source. There we go. Now we just need to connect it to the house and we'll be ready to turn it on. Because I have 2 power sources now, my SolarEdge system with the south-facing ground-based array, it produces 7.6 kilowatts and it needs a 40 amp breaker for the power that it feeds back. Our new system on the shed will only need a 20 amp breaker. I need to combine both of those loads before they go through the disconnect switch under the meter. So I'm going to make a slight detour. Instead of going straight through the switch into the meter, I'm going to come back into the garage and put in this 125 amp combiner box. Just be a regular 125 amp load center that has multiple spaces. I can combine the 20 amps from the shed, the 40 amps from my current inverter, and those will go through the switch and connect to the main load center with this 60 amp breaker. For wiring, I will use 12.3 from the shed through the 20 amp breaker, 8.3 from the SolarEdge inverter through this 40 amp breaker. These 2 breakers will be located in this combiner box. Then from the main lugs, I'll use 6.3 to go through the cutoff switch, and from there to the 60 amp breaker in the main load center at the meter. So let's put it together. If the shed was my only array, I would connect the shed's 12.3 conductor to this AC disconnect and run the output straight into my breaker panel to backfeed a 20 amp double pole breaker. Super easy. However, I first need to combine the output with my SolarEdge inverter inside the garage. So let's fish the wire into the garage and wire up the combiner box. I always measure several times before I drill a hole through the building, and most of my house is concrete, so this is about the only place where I can drill a hole. I'm using a conduit to carry my cable from the shed, even though it's direct burial, to make sure that it can't get damaged in the trip from the ground up through the building. And then I'll use some silicone to seal around it on the outside and the inside, just to make sure that no critters or water gets through. I rerouted the connection from my SolarEdge inverter here to our combiner box. This will be the power coming from the shed, and now this will be the power going back out to the meter. I already replaced the 8-gauge wire with 6-gauge wire running through the disconnect in order to carry the increased load of both arrays. And I replaced the original 40 amp breaker that supported just the SolarEdge inverter with a 60 amp breaker. Keep in mind, if you have a load center that is directly connected to the meter like this one, only the utility can disconnect the power. So make sure to have an electrician for these connections. So I'll just slide the box on and get this all wired up. I routed all the conductors behind the wall to keep everything nice and neat and clean. In order to do that, I had to put the clamps on the back of the sub panel and then tighten the screws right before I set it against the wall. From there, it's very simple. Strip the sheathing off the conductors back to the edge of the box. And then I always like to put a little bit of a bend in my conductors leading up to their mount points. That way there's room for heat expansion and adjustments later. The 6-gauge connects to the main lugs and then routes directly to the AC disconnect outside. Unfortunately, the ground wires were a little bit short, and so I had to route them less than ideal paths to the grounding bar, but it works out okay. The back feed breakers always go at the opposite end of the panel from where the main line comes in, so I'll put the 40 and 20 amp double pole breakers at the bottom of the panel. The 40 amp breaker takes the 8-gauge wire from the SolarEdge inverter, and the neutral goes to the neutral bus. The neutral from the shed will go to the neutral bar with all the others, and then line 1 and line 2 from the 12-gauge direct burial wire from the shed goes to the 20 amp breaker. It doesn't matter whether you put the red wire or the black wire on either terminal because the grid tie inverters will phase synchronize with whatever they see. It's a good practice to always go back and double check to make sure every lug was properly tightened. All right, there we go. We have our power connection to the breaker panel. Power in from the SolarEdge inverter. Power in from the shed and the string of Northern Electric microinverters. Now we can turn things on and make sure it all works. Sun's just peeking over the horizon. I turned on the breaker and the blade switch outside. Now it's time to turn on the breakers in our AC combiner box. I'll start with the SolarEdge system. It's powering up. We're over 400 volts, reading 246 volts. So the line power is connected. While that's powering up, let's turn on the shed array. The click click was the relays inside turning on. Now we can see 200 and some watts coming from the main array, 225 watts. And from the shed array, I can use a clamp meter to check the current going through one of those wires. 1.1 watts, 250, because we have 250 volts times 1 amp, that would be 250 watts. Now that array is facing due west, so we wouldn't expect it to be producing very much right now, but it's about the same as the main array, which is kind of interesting. So everything seems to be working. I'll let it run for a few hours, wait till the sun gets up a little bit higher, and we'll see how much power it's producing. My SolarEdge inverter's maxed out, and the one on my shed is producing near optimal. I'm at 40.5 amps on the 250 volt output. That puts us at 10,099 watts. I've exceeded the 10,000 watt mark for constant input into my house. That is super cool, and I can't wait to see the impact that has on my bills now. So the system works, it was easy to do. You can do it too. After closing up the panel, there are some labels you need to add for safety and code requirements. Codes may vary in your area, so check with your inspector, but these are the typical labels needed. You need a warning label on the outside of the box letting everybody know that the terminals can be energized in both the open and closed position. On a breaker, the terminals where the wires come in are not energized when the breaker is in the off position, but in a solar system, the breaker is backfed, so these can be energized even when the breaker's off. On the inside of the panel, on the door, you need a label letting everyone know that this panel is powered from multiple sources. In this case, it's powered from the grid through the main lugs, and it's powered from 2 solar systems, the shed and the main array. You have to add a label letting everyone know not to relocate these devices, and you need a label for each one of the breakers that is backfed, letting everyone know that is a photovoltaic source. One for the 20 amp breaker from the shed array, and one for the 40 amp breaker from the SolarEdge main array. Now that everything's labeled and closed up, we're good to go. Wow, the sun is out and we're producing power. This was the easiest and lowest cost per watt array I have done yet. The simple K2 rail system, the discounted panels from Santan Solar, and the low-cost NEP microinverters make a great value array anyone can do. The NEP microinverters daisy chain with a single plug. You only need 1 inverter for every 2 panels, and it all lands in a regular breaker panel. There was no setup required to initialize the inverters. I flipped on a breaker and everything just started working. I have wiring diagrams and links to the materials I used in the description below. Using the affiliate links to purchase your materials helps me bring you more content like this. I showed the cheapest and easiest way to set up the system. However, if you want monitoring, you can get a gateway to collect the data from the inverters over the AC lines and report it to the internet. In a future video, I'll show setting up the gateway and the initial performance results from my new shed array. So stay tuned, and I'll see you next time.